My name's Grace Knoll. For my project, I'm working with different perovskite materials with different cations. The different cations are methylammonium, cesium, and formamidinium. And basically, by changing the cation, you can change the properties of the perovskite.
My thesis project deals with thermal transport and nanostructured materials. Perovskites are a particularly new and exciting material with, at this point, undiscovered thermal transport properties. And this is where Grace's project this summer comes in. So, what are you going to do, Grace?
I was gonna take the solvent off of these crystals.
I see.
Yeah, dry them out. I'm gonna dry off these crystals. Is it okay if I use that vacuum?
Yeah, that's okay, as long as you set up the trap.
Okay.
Otherwise the solvent vapors will get in the pump, and that's dangerous. So why did you decide to use the tin foil for wrapping your solution?
So I used the tin foil and then I poked a small hole in it, and it controls the diffusion, so it's really slow. And I'm going to remove the foil.
Right, so when you attach the tube, you got to make sure that it's firmly attached, otherwise you won't pull vacuum through into the funnel.
Okay.
You've attached the vacuum line. Alright, next thing you should do is make sure you test that the vacuum is working and it's pulling solvent.
Okay.
You use a pipette and a small amount of volume to do that.
Just like this much?
Yeah, that's a good amount.
Okay.
So, not all of the solid got into the filter, so you can scrape some of that out directly in.
Okay. Should I be worried about breaking any of the crystals?
No, it's okay. They're pretty robust. Make sure to get as many of the orange ones as you can.
So these are the formamidinium single crystals. They crystallized for about 4 days. And these are the methylammonium single crystals. They're slightly bigger. You can see there's a difference in color. The formamidinium are more red in color. I am a rising senior at Penn State, and I'm studying chemical engineering. This summer I'm working in the Tisdale lab. My project is synthesizing these different perovskites in the two different forms, which are single crystals and microplates. Basically, the single crystals are crystals that are millimeters in size, whereas the microplates are a lot smaller, so they're more like microns in size. But they should exhibit similar properties to the single crystal. And the reason that this is advantageous is because the single crystals have properties that aren't disturbed by things like defects in the material or grain boundaries. So we have the 3 different types of microplates with the different cations, and we want to see if the thermal properties of them change based on their composition. So right now I am analyzing some SEM images of the microplates. These ones are formamidinium lead bromide perovskites, and basically they form these little plates that are about 1 to 3 microns in one dimension. So I'm looking at the microplates to see the different sizes that they are and looking to see if there are any defects or impurities. So the word perovskite refers to a class of semiconductors that have a specific crystal structure. And they're an interesting area of research. They're semiconductors that are interesting for photovoltaic applications.